Okay, hello guys, I hope everybody is alright. So today we will learn file input output operations in C++. Okay, in C++. Okay. We have learned already what is going on in ANSI C. Today we will check IO operations in C++. Okay, and the topics are similar, and there are two types of binary and text files, and how to check files logically, and what's a file, we already explained that one, and how to reach a file, open, read, write, and close. Okay, we will see in C++ style. iOS, this is a base class that contains everything about operating systems, I'm sorry, streaming operations, which means input and output from hardware to memory and from memory to hardware. Okay, so there are three derived classes. These are eStream, input stream, OStream, output stream, and IOStream. Okay, and these functions are sitting in those classes. Okay, in the future you will learn what does it mean, class and etc. Okay, an object, whatever. So in C++, we got to use fstream.h. This library in order to run file IO operations. Okay. Okay, this is an object, and we are defining a file object, which is an input file. Okay, and this input file, since it's an if stream, we are able to only read from this file. Okay, and in this file object we are able to use open function and give the file name, and this function opens my customer dot file and data file for reading. In off stream we are able to open the files and then write, and this is write only operations. Okay, and if there is a file already and it has something in it, and if we open with off stream object, which means it will be truncated, which means all data in the file will be deleted. Okay, okay, so we are not able to read from this file because we open it with only write only option. Okay, and similarly with if stream object we are able to open a file for only reading. Okay, and if there is no file in the system, in the disk or the target space, target folder, and there will be a failure. Okay, and for both operations we are able to use this library or object. Okay, and with this object we are able to open a file for reading plus writing plus appending. Okay, okay, there are file modes, opening modes, and that we are using in open function. Okay, so we are giving a file name, target address, in the folder, in the disk, in the partition, whatever. So this is the target name, and then we are giving a open mode. Okay, opening mode. So iOS append means we are opening this file for appending or writing something to the end. So the data in it, we are not deleting it. Okay, so there is one more opening mode. So with this option, okay, with this mode, we are able to jump around the file. Okay, but in this mode we are always jumping to the end of file, and if we want to write something, we are writing to the end, we are writing to here. Okay, okay, if the file is binary, or if you want to open a file in binary mode, we are basically using this like flag. Okay, so default, if we don't say anything about binary or text, and it is text in default. And with this flag within the open function, so this is a parameter, right? With this flag, when we open a file, which means we are opening this file for reading. Okay, if the file doesn't exist in the system, in the target folder, that means we are not able to open it. There will be a fail, okay, opening failure, and then it will not be created. So it's not, there will be no new file in the target folder. Okay, no create. So for iOS app function, if there is no file already, so this no create flag doesn't generate a new file. So it's basically manipulating or helping flag for us. So iOS app, let me tell you this. If we use this flag, okay, let's say this guy basically opens a file if there is not any, generates a new file, opens or generates a new file if there is not any. With this flag, that means this guy cannot generate a flag, a file. Okay, no replace. Okay, with this guy, let's say we want to open with outputs, iOS out. That means we will generate a file if there is not none. Okay, if there is not a file in this system target folder, which means we are generating a new one, right? If the file exists, in that case, let's say there are something in it. In that case, this flag will tell us that there is a failure. Okay, so existing file will not be opened, which means we are not deleting anything. Out. Okay, this was the opposite of in, iOS in. When we open a file with this option, with this mode, which means we are basically open the file for write ability. Okay, so by default the file contents will be deleted. Okay, let's say you have a lot of data in a file and you open the file with this flag only. That means you have a lot of data in it. What happens, this opening mode will basically delete everything and there will be a fresh file. Okay, so we got to be careful by using these flags. Okay, truncation. And when we open a file and with this flag, which means there is if there is something in the file, all the data will be deleted. So it's basically already in this flag. Okay, so when we use this flag, that means we are already using this flag. So we got to be careful. Sometimes, let's say you have a file, usually dump files, which is test files, right? And it's getting larger and larger. Let's say when we run a test, another test, you want to delete everything in it and you want a fresh file. So in that case, we are basically using this flag. Okay. If we want to keep the data in the file, that means we need to open with app tag or flag, which means we are able to write everything at the very end. We are not deleting anything. Okay. So I think it's clear. So there are a bunch of examples here. First of all, there's a fstream object. Okay. And this is my object. Now it will hold the function when we open it. So we are getting data from the user file name. So when with this object, we are able to run this open file and without flag, which means we are generating a file either within this folder or the target folder, right? And everything in this file will be deleted because of this flag. And then right after that, I'm basically telling that this file is opened. Okay, and this is the output. So for opening a file for reading and writing purpose, in that case I need to use fstream, right? Not ifstream, not offstream, fstream, and I'm able to read and write on this file. Okay, again, since I'm and this notation is basically telling us or. Okay, logical or. You already know that, just to mention again. Okay, another example. So it's always good that when we open a file, it's always good that we open that file in a correct way. Otherwise, let's say we think that we open the file, but something wrong with the system, so we cannot open it. Otherwise, in here, let's say I want to do something reading or writing operations, which I cannot, right? I won't able to. Okay. So, this function will tell us, and there is an opening failure or correct opening success. Okay. So another example, and data file dot opening in reading and writing mode. Okay, we can open this way. Okay, and usually data file with fstream, which is a basically pointer, and then dot pointer, and we cannot open this guy, there will be null, right? So reverse null means there's an error, and then we are printing the error message. Otherwise, we open correctly. Okay, this is another way of checking that we open a file in a correct way. Okay, when we open a file for reading or writing for any purpose, okay, and we can do anything, any operations on it. I mean, if we are allowed. And at the very end, if we don't close, and operating system knows that somebody is using that file, and then let's say some other program you may see in Word, right? Let's say you already have a Word document and you are using it, and then sometime later you want to open it with another program, or let's say printer, and printer program will say that this program or this file is used by somebody else. Okay, so when you close that program, in that case that printer is able to reach that file and then print it. Okay, again, it's always good to close file when you are done. Okay, so here we are opening a text file for writing mode, and then we are checking then if we open that correctly. These are basic structures, and at the very end we are closing. Okay, okay, so as you remember, for cin we have these operators, right? Which means the input data, I'm sorry, cout, anything in here, the message or the data, whatever, goes to screen. So this means goes to screen. Okay, so in this case goes to file. This message goes to file, which means we are writing this message to the file. Okay, so another example, we open a file for writing. Now we are writing these names to the file. Okay, and then at the very end we are closing the file. Okay, so when we run this program, we will see these message on the screen, and when we open my text file, demo file, we will see these names, right? So these are in file, and this will be on the screen. And what else? Do you have any questions? Okay, when logically the file looks like this. So there is name and some new line and another name, Smith, new line, and then at the very end there will be not logically a key or character. So that means we are done with the file. Okay, if we want to read, let's say we are here, if we want to read something else, and since there is not any, that means end of file function will generate that, will say that you have reached end of file. Okay, that's basically a logically the limit. Okay, so in here we have a file object, and then we open the file. In here we got to check that if we open the file correctly, right? So there is something wrong, or some more actions we got to do. So we have messages here, let's say 2 names, and then we are closing the file and etc. Moreover, okay. So we are opening the file again, but in this case we are using append mode, which means the file inside the file, we are not deleting anything. We are writing something else to the end, right? So there will be Willis and Davis. And then we are closing the file again. So in a program, we are able to open a file in different way, but we got to close it first. Let's say if we forget to close the file and if we wanna reopen with append mode, there will be error, right? Here. It will say that it's already open. You are not able to reach or have that access right. Okay. And we know that the file inside the file, we will see these messages. Okay. So we are able to format the message with cout and cin. Okay. So we have a number here, and then we open the file. If something wrong with it, we are printing the message and return. We are returning here because that means if something wrong with the opening file, we are not able to reach the file at all. Okay, anything here will be wrong. Okay, so we are getting the number. So here these commands or functions are writing my message to the screen, right? And these commands or lines, okay, and these are written to the file. And it looks like this. So we are printing 6 characters in here. I don't know why it's not counting the point, okay? And with set precision 5, in that case, it's printing only 5 characters, 4 characters, 3 characters, okay? So we are basically limiting the size of the message. Okay, so here is something wrong. We got to write something here. Curly brackets, curly brackets. Okay, so we have an integer array, 2D array or matrix. We open a file for write mode, and we are writing same message with the length of 4 bytes to the screen as well as to file. Okay, so these for loops are writing same message to screen as well as to file, and then at the very end we are writing new lines in file and on screen. Okay, and be careful, we are always closing our file at the end. So we will have something like this because after writing any symbol message in 4 bytes, we have a space and then we are writing 4 bytes again. That's why it's formatted output. It looks correct and it's aligned. Okay, as you see, all the message are aligned. Okay, and as you see, there's a new line, and at the very end I have logically the end of file. Okay, this operator, as you remember, it's basically reading characters from the source or stream. Okay, so let's say we open a file, checking that if there is a failure or not, and then printing messages to screen. And in here, what happens? We are reading, oh, this guy is reading, oh, we are opening the file for reading, right? We are reading from file and then saving the data to name. Name is a string, right? Yes, name is a string. And then printing the screen. At the very end, we are closing the file. So what we are doing here, we are opening file. In the file, we have these names, right? Jones, Smith, Wellens, and Davis. So Jones come here. So we are reading one line or one element from here and writing to the screen. Another line and then writing that line to the screen as well as to the end. Okay. So there is an end of file function detecting the end of file. So that means if we are trying to read something from the file, and the file will say that there is not any bytes or extra bytes that we can read. That's why we have reached to the end of file. Okay, so examples are simple and straightforward. First of all, we are opening a file for in mode. If something wrong with the file, we are printing the message and return. Okay, now here there are more messages to the screen, and then we are reading one element from the file, and then we are getting into loop, right? Until the end of file, this simple line tells me that until the end of line, read all the names in chunks, and then I'm sorry, yes, data file, write all the names to the screen and then read the next name. If we are at the very end, let's say we are end of file, which means we cannot read any, right? And this function will tell us that we have reached the end. That means we are not able to read or write any message. We are done. Okay. And what else? Yes. Okay. Really, logically, there is no end of file characters that tells us that which is sitting at the end of file. Okay, so end of file function basically tries to read one more byte from the file. If we have reached to the end, that means end of file bit or label will be 1. Okay, so let's see. First of all, we have two files. This is file, and then we are opening a file and file name, data file, and opening file function is sitting here. We are opening the file in read mode. If something wrong with it, we are returning the message, or we are returning the error false. Otherwise, we are returning true, right? Okay, we are writing these messages to the screen, and then we are reading data from the file. Data is 81 characters string, and then we are printing that data to screen, right? And then we are reading another 81 characters. That's why we are basically reading line by line, and at the very end we are closing the file. Okay, so there are more options that we can check errors during the stream operations. These are the guys that we can check and set. I of bit, so end of file function checks that if this bit is set, that means we are at the end of the file. Failed, which means we want to something to do on the file and then it's not accepted or operating system doesn't allow. That means there's a failing bit. Okay, or there is one more much more sophisticated error. When there is an uncoverable error, in that case this bit is set. Setting means set or reset. Setting means usually 1, making the label 1 or this bit 1. Resetting means reset, making this bit 0. One of these bit is 0. Okay, again these are called flags, and these are basically helping us to do file operations, file input output operations in C++. Okay, so again there is one more explanation, so I got to make it clear. Maybe I want to remove one of these guys. Okay, how many examples there? Yes, good bit end of file, and these are functions that are checking these bits. End of file checks that end of file bit. If there's a fail flag is set or 1, and this function will tell us there's a failure. Okay, again these are functions that are checking corresponding bits or control bits. Okay, one more example. During the file operations we can get the status data by running some functions like this. In that case, if we reached the end of file, if there is an error or failure on the file, if there is a bad operations on the file, if there is a good operations on the file, okay, if the good operation is 1, which means these are all 3 are 0. Okay, review. So we learned C++ file IO operations. File IO. We have learned bigger than, which means for reading, less than for writing, right? And what else? We know that there is a append mode, which means we have the file and we have data in it. With append mode, we are able to add new data to end. Okay. Do you have any questions? Evet, soru olan var mı arkadaşlar? Sınav kağıtlarını okuyorum dediğim gibi. Hemen hemen herkeste benzer hatalar var. Ve bu kadar benzer olması tabii ki hani şey eşit değil. Çünkü normal dağılıma göre sınıfta 100 alanın da çıkması lazım. 30 alan da çıkması lazım. Bu dağılıma göre herkes 60'larda 70'lerde birikecek. Tabii 30 alan yine var. Büyük hatalar yapanlar var. Veya hiç sisteme yükleyemeyenler var. Veya belki de hiç girmedi. Onlar da var tabii. Ama sınav kağıtlarını, sınav sorularını şöyle bir daha gözden geçirmek isterdim. Ama bunu bu dönem dediğim gibi çok yoğunum. Çünkü birkaç tane bariz hatalar yapıyor. Şeyde katedeyken son sınıflara falan ders anlattığımda çocuklar bu bariz hataları son sınıfa kadar düzeltmemiş oluyorlar. Demek ki ta birinci sınıftan birikiyor. Bunu gelecek dönemlerde eğer dersinize girersem veya yani bir daha elden geçirmem gerekiyor. Öbür türlü şey eksikler var. Yani çok doğru bildiğiniz şeyler bile yanlış sonuçlar türetiyor arkadaşlar. Tamam. Kendinize iyi bakın. Dediğim gibi gelecek hafta büyük bir ihtimal yaklaşık bir 50 slide daha var. Bitiririz. Ondan sonra e, herkes işine bakar. Kendinize iyi bakın. Kolay gelsin.